Now in this question there is a cylinder in which there is a pipe attached to it along the diameter, and there is a block placed in the pipe with two springs, and the ends of the springs are connected to the cylinder as shown in the figure. The block is displaced from the center by a distance x, and the whole system is released, and just after the release we have to find the acceleration of the center of the cylinder. So this is the question. Now consider the cylinder first. Let its acceleration be a and angular acceleration be alpha as shown in the figure. Then take a point S. Suppose it is a point where block is placed, and the acceleration of this S with respect to ground, we use the formula, will be acceleration of center with respect to ground plus acceleration of S with respect to center. If you add these two, you'll get acceleration of S with respect to ground. Now acceleration of center with respect to ground is this A, so it's simply A, and the acceleration of S with respect to center. So with respect to center, it is a circular motion. S is moving along a circle with respect to center, and therefore we have two accelerations in the circular motion, one along tangent, that is r alpha, and one along the center, that is omega square r. So it will have two acceleration. One is x alpha. X is the distance from center, so its radius is x, and the other is omega square r, and again we have x in place of r. And since omega is 0, because the system is just now released, it hasn't picked up any omega yet, so omega is 0, so this term goes to 0, omega square x. So we have these two accelerations. These are the accelerations of point S where block is placed. Now if you take a point P is a point which is in contact with the lower surface, and there are again two accelerations. One is acceleration of center with respect to ground, that is A, and one is acceleration with respect to center, and that is due to the circular motion. So again we have two accelerations, r alpha and omega square r. Omega square r is again 0, omega being 0. These are the two accelerations, and since it is rolling, A and r alpha, these two are equal numerically, so they cancel out and acceleration of P becomes equal to 0. Now this is the block which is placed inside the tube, and the acceleration of block with respect to ground is acceleration of block with respect to S. S is a point here on tube, and acceleration of S with respect to ground, we have to add these two. We have just found acceleration of S with respect to ground, and suppose with respect to pipe, this block is moving with an acceleration A dash. So this is the acceleration of block with respect to S, or with respect to pipe you can say, and then acceleration of S with respect to ground. So it has two components, one is A and one is x alpha. These accelerations make up the total acceleration of the block, and its force diagram if you say. So there are two springs connected to the block. Both springs will exert the force in same direction because one is stretched and one is compressed, and mg, apart from that normal reaction of the pipe. So these are the forces acting on block, and if you write Newton's law along this vertical direction, we have this mg minus n is equal to mass into acceleration in this direction, that is x alpha. So this is the equation of block. Okay, again consider the cylinder and its pipe. So this is the system, and the forces acting on this are kx, because the spring here was stretched, so the stretched spring will try to come to its normal length, so it will apply a force like this. And the spring here was compressed, so it will apply a pushing force on the cylinder. Apart from that, block is placed here, so it will exert a normal force, the weight of cylinder, and the normal of ground, and there may also be some friction from ground. So these are forces acting on the cylinder, and if we apply torque is equal to alpha about P. So about P, no pseudo force, as acceleration of P with respect to ground is 0, we have seen just now. So since P is not accelerating, so we don't have to apply any pseudo force, and now I'm going to apply torque equal to alpha. So N will have torque N into X, while both these Kx forces, they are at a distance of R from P, so they'll have a torque 2Kx into R, so that is equal to I. So moment of inertia about this P will be moment of inertia about center plus shifting, so that will make 2mr square into alpha. So these are the two equations which we need to solve. And again r alpha is A because of a rolling condition. So these are the two equations we obtained, and we have to solve for A. So simply putting the value of n from first equation into another, we'll get this. So what I'm doing, I'm bringing this A term on the same side, all A term on same side, and here we'll be left with two terms, and then I'm taking x common. So it's like this. Now I'm taking A common from these two, and then I'm bringing this whole in the denominator. So this is the expression for a we get finally.